Hello and welcome students. I again welcome you in lecture number 5 of this chapter, carbon and its compound. So let's begin this lecture, and here we will talk about chain, branches and rings. Okay, so I told you that carbon has the ability of catenation. So that's why it will form chain, branches and rings. Okay, we saw that carbon compounds methane, ethane and propane. So what is methane, ethane and propane? These are carbon compound, and for methane the formula is CH4. For ethane the formula is C2H6, and for propane the formula is C3H8. Okay, now guys, you can see that where one carbon is present, we call it methane, or we are adding a prefix meth. And here, where two carbon is present, we are calling it ethane, and we are adding eth as a prefix. And guys, where there is a presence of three carbon atom, we are calling it propane. Propane. Okay, now guys, there can be more carbon atom, so we will call it according to the number of carbon atom. Okay, so here you can see these chains. Here only one carbon is present, in this chain two carbon is present, in this chain three carbon is present, or you can say this is the chain of three carbon. Now this can be C4H10. C4H10. Here you can see this is the chain of 4 carbon atom, and this is pentane. In pentane, this is the chain of 5 carbon atom. Okay, and in hexane, where 6 carbon atoms are present, this is the chain of 6 carbon atoms. Okay, so we will name these compounds according to the number of carbon atom. I hope guys this point is clear to you. So first one is methane, second one is ethane, third one is propane, fourth one is butane, fifth one is pentane, and sixth one is hexane. Or you can also say for one carbon we use the prefix meth, for two carbon we use prefix eth, for three carbon we use prefix prop, and for 4 carbons we use this prefix but, and for 5 carbon we use this prefix pent, and for 6 carbon we use this prefix hex. Okay, so I hope guys these points are clear to you. Now let's move on to the next slide and let's talk about the other important point. Okay students, so if we make the carbon skeleton with 4 carbon atoms, we see that 2 different possible skeletons can be. Now guys, we all know that if I want to make a chain of 4 carbon atoms, so there are 2 possibilities. First one is this and the second one is this. Okay, here what did I do? I connected this carbon here and then I connect this carbon here. So basically this is a branch structure and this is a chain structure. Okay, so guys, this is a chain of carbon. Sorry, this is a chain of carbon and this is a branch of carbon. I hope guys this point is clear. So if I fill the remaining valencies, so I will get this structure like this. If I fill all remaining valencies, I will connect this hydrogen here, then I will connect this hydrogen, then will this hydrogen, and then this carbon is already connected with this carbon, and you can check that all the valencies are completed or all the valencies are satisfied. Now here also you can see that all the valencies of carbon is satisfying, 1, 2, 3 and 4. And the same way the valencies of this carbon is also complete, and here also if I talk about the last carbon atom, then the valencies of this carbon atom is also satisfying. Okay, now if I do the same thing with this carbon branch, then you can see that all the valencies of carbon are satisfied. So guys, we see that both these structures have the same formula C4H10. Here basically this is C4H10. Okay, such compounds with identical molecular formula but different structure are called structural isomers. These are known as structural isomers. This is very important stuff. Now guys, what are the structural isomer? So you can say that the compounds which has same molecular formula. Now what is molecular formula? You can count the number of carbon, 1, 2, 3, 4. So it means in this compound 4 carbon is present. Now how many hydrogen is present? You can count it, 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so basically here 4 carbon is present and 10 hydrogen is present. Now if I talk about this branch structure, so here also you can check that 4 carbon is present, 1, 2, 3, 4. Okay, so I will write it here, 4 carbon, C4. And now if you count the number of hydrogen, then 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. It means 10 hydrogen is present. So this is the molecular formula for this. Okay, and this is the molecular formula for this structure. Now guys, you can observe that the structure is different. This is a branch structure and this is a chain structure. Okay, but the molecular formula is same. This is also C4H10 and this is also C4H10. So guys, thus we can say that such compound which have same molecular formula, okay, or with identical molecular formula but different structure, these compounds are known as structural isomers. Okay, so I hope guys this point is clear to you. Now if it is clear to you, so after understanding this point, let's move on to the next slide and let's try to understand the rings of carbon. Okay students, so here we will talk about that in addition to straight and branch carbon chains, some compounds have carbon atoms arranged in the form of a ring. Okay, so I told you that apart from the chains and the branches, there are rings as well. So we will call them cycloalkane, okay, or cycloalkene. So basically guys, we take the example of C6H12. Now because there are 6 carbon and I have also written cyclohexane, it means the ring of the carbon is present. So hexane is denoting that there is the presence of 6 carbon and N is showing that there should be only single bond. So guys, here This is the ring of carbon, and all the carbon are attached to other carbon with single bond. Now, if I complete the valencies, then this structure will look like this. Here, all the valencies of carbon are satisfied. Okay, now this is a saturated carbon ring because there is only single bond. Now, these straight chain, branch chain and cyclic carbon compound, these compounds which are present in the form of ring, these are known as cyclic carbon compound. I am highlighting this here for you. These are cyclic carbon compound. So these may be saturated or unsaturated. Saturated are what? Where only single bond is present. And unsaturated is what? Where double and triple bond can also be present. Okay, now if you are asked that tell us the example of a unsaturated cyclic carbon, so you can give them the example of C6H6. This is benzene, and this is very important compound. This will be used very frequently in the chemistry. So guys, this benzene has the structure like this. As you can see that this is a cyclic carbon compound. So all 6 carbon will be in the shape of ring, and there will be a double bond 3 times. Between this carbon and this carbon there is a double bond. Here also there is a double bond, and here also there is double bond. And then the remaining valencies will be satisfied by adding hydrogen. So 6 hydrogen will be attached to this. 1, 2, 3, 4, 5 and 6. So this is the structure of benzene. Now guys, this is unsaturated cyclic carbon compound. Why? Because there is a presence of double bond as well. Here only single bonds are present, but here because there is a presence of double bond, that's why this cyclic carbon compound is unsaturated. So I hope guys this point is clear to you. Now if it is clear to you, so let's move on to the next slide. So students, all these carbon compounds which contain only carbon and hydrogen are called hydrocarbons. Let's suppose CH4. This is what? This is hydrocarbon. Hydrocarbon. And why it is hydrocarbon? Because there is only the presence of hydrogen and carbon. Okay. If I say CO2, then is it hydrocarbon? No, because with carbon there is presence of oxygen, okay, and no hydrogen is present. So that's why it is a carbonic compound, but this is not hydrocarbon. Okay. Now guys, among these, saturated hydrocarbon are called alkane. Saturated hydrocarbon, we know it very well that what are saturated hydrocarbon. This CH4, it is what? This is a saturated hydrocarbon. Saturated hydrocarbon. And why it is saturated hydrocarbon? Because there is only the presence of single bond. If I draw the structure, then it will look like this. Are you able to see any double bond? No. So because there is no double or triple bond, there is only single bond. That's why this is saturated hydrocarbon. Now guys, let's take an example of another alkane, that is ethane. Ethane. Okay, for single bond we use this ane. Okay. Now, because the prefix here is H, it means 2 carbon is present and they are connected with only single bond. Now, if I satisfy the remaining valencies, then this is the structure of ethane. Here also you can see, because there is no other bond than single bond, that's why it will also be called alkane. Okay, now guys, let's talk about the unsaturated hydrocarbon which contain one or more double bonds. So these are known as alkenes. These are known as alkenes. Let's suppose I'm taking an example of ethene. Okay, what is the formula of ethene? C2H4. Now, because H is coming as a prefix, that means there is a presence of 2 carbons. Now, you can see ene is coming here. It means there is a double bond between these 2 carbon atoms. So I will make a double bond and then I will complete the remaining valencies. Okay, so this is the structure of ethene. Now guys, here, because there is a presence of double bond, that's why this ethene is a alkene. Or these compounds, these unsaturated hydrocarbon where there is only double bond, so this is known as alkene. I hope guys this point is clear to you. Now let's talk about the alkynes. So I hope most of the students have got this idea that what are alkynes. So those compounds which contain one or more triple bonds are known as alkyne. Let's talk about ethyne. Ethyne, let me write it here. So this ethyne is an example of alkyne. Why? Because the structure of this ethyne will be like this, where a triple bond is present. So because of the presence of this triple bond, this is a alkyne. Triple bond. Okay, so I hope guys this alkane and alkene and alkyne, the difference between these 3 points or these 3 words are clear to you. Okay, alkanes are where only single bond is present or saturated hydrocarbon is there, or what is alkenes where one or more than double bond is present, and what are alkynes where one or more triple bond is present. So I hope guys this point is clear to you. If it is clear to you, so let's move on to the next slide and let's talk about the other point. Okay student, so here we see what is heteroatom. Okay, so carbon also forms bond with other element as well. Yet we have seen carbon is forming bond with other carbon and with hydrogen, but carbon also form bond with other elements such as halogen. Now what are halogens? Chlorine, bromine, fluorine, these are what? These are examples of halogens. Okay, and carbon also forms bond with oxygen, nitrogen and sulfur. So guys, in a hydrocarbon chain, one or more hydrogen can be replaced by these elements such that the valency of carbon remains satisfied. In such compound, the element replacing hydrogen is referred to as heteroatom. So basically what I am trying to say is, let's suppose we have a compound CH4. Now if I draw the structure for this CH4, then it will look like this. Okay, now guys, sometimes what happens, if this H is replaced by another atom, okay, or with other element. If this hydrogen is replaced by the other element, then that element will be known as heteroatom. Okay, let's suppose, let me give you an example. This hydrogen is removed by a chlorine atom. So this will become CH3Cl. So here what is this chlorine? This chlorine is heteroatom. Okay. Now let's suppose if this hydrogen is replaced by OH. This is alcohol. This is alcohol and hydrogen is replaced by this OH, then this will become CH3OH, which is methanol. Okay. So I hope guys this point is clear to you. Now guys, sometime what happens, these heteroatoms can also be present in some group. Like here you can see this OH is group of two elements, this oxygen and this hydrogen. But here you can see this is chlorine and this is a single element. Okay, so the heteroatom can be present as a single element as well as with the combination of two elements. So I hope guys this point is clear to you. Now here some compounds and the functional group are given. Basically these heteroatoms can also be in the form of functional group. Let's suppose this OH, this is the functional group, alcohol. This is CHO, this is aldehyde. This is C double bond O, this is ketone. And this is C double bond O and then OH, this is carboxylic acid. Okay, so I hope guys this point is clear to you. Now let's move on to the next slide and let's talk about some point related to these heteroatoms. So these heteroatoms and the group containing these confer specific properties to the compound regardless of the length and nature of the carbon chain and hence are called functional group. Okay, basically guys what happens, let's suppose this is CH4 and here one hydrogen atom is replaced by this alcohol OH. Okay, now let's suppose we have another atom and that is C2H6. Now again one hydrogen is replaced by OH, so it will become C2H5OH. Now guys, here this OH will confer its property to these compounds. Okay, it doesn't matter that how long a chain is. It might be only with one carbon, it might be two carbon, but they will give it the properties of alcohol. Okay, now guys, free valencies or valencies of the group are shown by the single line. You can see here. Here, this single line is what? This is showing a free valency. It means hydrogen can be replaced from here or it will connect to the carbon from this side because these are the free valencies. Now, the functional group is attached to the carbon chain through this valency by replacing one hydrogen atom or atom. Okay, I have already given you the example that how these functional groups replace hydrogen and get attached in the place of hydrogen. So I hope guys this point related to this functional group is clear to you. Now let's move on to the next slide and let's talk about the other important point. Okay students, so here we will see what is homologous series. Okay, so I told you that the presence of a functional group such as alcohol, this will decide the properties of the carbon compound, and it doesn't matter that how long your carbon chain is. It might be CH3OH, C2H5OH, C3H7OH, C4H9OH, but their chemical properties will become very similar because the hydrogen is replaced by the same functional group. If I give you the example by drawing the structure of this, let's suppose CH3OH. Here hydrogen is replaced by this OH. This hydrogen, and this hydrogen will be replaced by this OH. And here in C2H5OH, what will happen? Let's suppose this is hydrogen, this is another hydrogen, and here the OH will be attached. Okay, now this will become C2H5OH. So that is what I was trying to make you understand, that here the same alcohol is replacing one hydrogen element. That's why it is giving its properties, or you can say the chemical properties of this long chain CH3OH, C25OH, C3H7OH will be very similar because hydrogen is replaced by the same type of functional group. Now guys, hence such a series of compounds in which the same functional group substitutes for hydrogen in a carbon chain is called homologous series. Okay, so homologous series is nothing, it's not a rocket science, it's very easier to understand that where the hydrogen is replaced by the same type of functional group, that series is known as homologous series. Now guys, if we look at the formula of successive compound, let's suppose CH4 C2H6. Now guys, here what I am telling you, this is very important. This is very important. By this we will make the formula of alkane, alkene and alkyne. I told you what is alkene, where double bond is present, and I also told you what is alkyne, where triple bond is present, and I also told you what is alkane, where only single bond is present. Now guys, you can see CH4, and the formula for CH4 is methane, like the name of this CH4 is methane. Then C2H6, this C2H6 is what? This is ethane. Now what is the difference between this ethane and methane? There is a difference of CH2 unit. Okay, if I add this CH2 unit in this methane, then it will become ethane. Now what is the difference between C2H6 and C3H8? So it also differ with CH2. If I add this CH2 in this C2H6, then it will become C3H8. So guys, here we can generalize this statement that for all the alkanes, we can say CnH2 and plus 2. Okay, so this can be the general formula for alkane. Okay, now what can be the general formula for alkene? The general formula for alkene can be CnH2n, because what if I want to write ethene? So in ethene there is a presence of 2 carbon atoms. So because there are 2 carbon atoms, so N will become 2. So if I put this 2 in this formula, then it will give me C2H4, and this is the formula for ethene. Okay, if I want to write the formula for ethane, then there also 2 carbons is present. So if I put this N, the value of N will become 2, and if I put this N in this formula, then this will give me C2H6. Okay, this N will multiply with this 2, and then it will be added with this 2, and it will give me 6. So that's why this is the formula for ethane. Okay, so I hope guys you might have been able to understand what I am trying to say. The general formula for alkenes is CnH2n and the general formula for alkanes is CnH2n plus. So let's move on to the next slide and let's talk about some points. So guys, here on this slide, we will talk about some of the examples. Okay, by the help of the examples, it will be easier to understand what we have seen. So the first question is, what is the difference between propane and butane? So I told you this propane is what? This is alkane. Okay, because this N suffix is coming in N. So the general formula for alkane is CnH2n plus. Now here prop means 3. Prop is for 3 carbon atoms. So it means the value of N will be 3. So if I put this here in this formula, then this will give me C3H8. So this is the formula for propane, and this is butane, and the formula of butane is already given, C4H10. Now guys, we all know that alkanes differ with CH2 unit. CH2 unit. So what is the difference between this C3H8 and C4H10? CH2. These differ with CH2. Okay. Now here another question is, can you find out the difference in molecular masses between these pairs? Of course, we can find out the difference. The difference between the propane and butane is CH2 unit. And what is the molecular mass of carbon? In this question, you have been given the molecular mass, and that is 12 unit. Okay, so 12 unit of this one carbon plus the molecular mass of hydrogen is given 1 unit. So we will multiply this with 2 because 2 hydrogen atom is present. So it will give us 14. So it means the difference in molecular masses is 14. This is our answer of the second question. So I hope guys this point is clear to you. Now the last point is, what is the general formula for alkane and alkyne? So guys, the general formula for alkane is already written here, CnH2n plus 2. CnH2n plus 2. And what is the general formula for alkyne? So this will CnH2n minus 2. You can also check. Let's suppose if you want to write down the formula for ethyne, then for H it means 2 carbon atoms is here. So if I put this 2 here, then this will give me C2H2. So this is the formula of ethyne. So I hope guys, by the help of the example, you might have been able to understand what I am trying to say. So let's move on to the next slide and let's talk about the other important point. As the molecular mass increase in any homologous series, a gradation in physical properties is seen. So basically guys, the chemical properties can be identified by the functional group. Okay, but the physical properties depends on the molecular mass. If molecular mass increases, then the physical properties, you can see a gradation in physical property. This is because the melting and boiling point increases with the increases molecular mass. So guys, you can see that the molecular mass is dependent, or you can say the melting and boiling point is depending on the molecular mass. So if I ask you a very simple question, that there are two compounds CH4 and C2H6. So which one has higher molecular mass? Of course, this C2H6 has higher molecular mass. So guys, if I ask you which has high melting point, so this C2H6 has high melting point. Why? Because it has high molecular mass. Okay, Now, other physical properties such as solubility in a particular solvent also show a similar gradation. But the chemical properties which are determined by the functional group remain similar in homologous series. So what this line is trying to say, I had already told you that the chemical properties can be determined by the functional group. Okay, let's suppose CH3OH and C2H5OH. Here the same functional group is replacing the hydrogen. It means the chemical properties of these two compounds are same. Okay, but physical properties is different because the mass, the molecular mass is different. Here this differs with CH2 unit. This differs with CH2 units. So there is a difference of mass of 14 unit. Okay, the mass of carbon is 12 and mass of hydrogen is 1 and mass of 2 hydrogen will 2. So that's why there is a difference of 14 units. So I hope guys this point is clear to you. Now guys, if it is clear to you, so let's move on to the next slide and let's talk about some of the examples so that our concept will get more clear. Okay students, so here we have been asked that calculate the difference in the formula and molecular masses for CH3OH and C2H5OH. Okay, so this is methanol and this is ethanol. I will be teaching you the nomenclature in the upcoming lecture, so you do not need to be so much stressed that how am I able to determine the name of these formulas. Okay, so you do not need to be worried about that. Now guys, here the question is, what is the difference in formula? So you can see there is a difference of CH2 unit. Here 1 carbon and 2 hydrogen atom is moved. Now what is the difference in molecular mass? So 14 unit is the difference of molecular mass. How? This carbon has 12 unit of molecular mass and this hydrogen has 1 unit, but if it is multiplied by 2 it will become 2. So the final answer is 14 unit. Okay, the same way you can also say that if I write down the solution for this B, then here also you can say that the difference here is CH2 unit and the difference in molecular mass is 14 unit. Now the second question is there any similarities in these? So definitely there is a similarity that these are alcohol. Okay, their chemical properties are same because here hydrogen atom is replaced by the same type of functional group. Okay, so I hope guys these points are clear to you. So now I am ending this lecture and we will meet in the next lecture. Till then, thank you so much and bye bye.